We came across this problem on Preesh Talwalkar's channel, which reads, a ladder is placed vertically on a wall. What shape does the midpoint of the ladder trace as the ladder slides against the wall to the floor? Let's try to see this through an animation and see what graph the midpoint of a ladder plots. To simplify, we would assume a line segment of unit of length 2 as a ladder on y-axis and slowly move its end on x-axis from unit 0 to unit 2. Let's see what curve midpoint plots. As you could see, it plots a quarter circle. You might want to see Preesh's original video for mathematical explanation why this happens. If we slide in a way that it travels all 4 quadrants, we see it plots a perfect circle with radius of unit length 1. Now, curious question. What if we pick any point other than a midpoint? Let's choose a point on a line segment which splits the line segment into 1/3 and 2/3 of its length. Let's see what curve it plots. As we see, it plots an ellipse. And both section of a line segments becomes to radius, A and B, of an ellipse. When we choose a midpoint, it draws an ellipse with both radius A and B are equal, resembling that circle is a special case of an ellipse, where both of its radius are same. This property can be used to draw an ellipse, and there are several instruments which works on a similar principle, like trammill of Archimedes and Tussi couple. Let's now try to see how different points on line segments would plot different ellipses. Let me know if you like this video. Thank you.